And I have started the recording also.
Recording, yeah.
Yeah.
All right. Okay.
So, okay. A very good evening, all the participants. Welcome to the day 5 of session 9. Today, we have with us Mr. Mayank. He's a seasoned program manager with around 20 years of experience driving successful outcomes in the dynamic telecommunications industry. As a program manager at Nokia, a global leader in technology and innovations, he leverages his expertise in technical project management, solution consultancy, and operations to deliver impactful results. And Mayank possesses a strong foundation in project management methodologies, holds certifications in PMP, Six Sigma, and ITIL foundations. Throughout his career, Mayank has successfully managed not only high impact projects, also high budget telecom projects across diverse product portfolios and technologies. And Mayank is a passionate advocate for innovation and remains at the forefront of the evolving telecom landscape. And he actively seeks opportunities to leverage emerging technologies and industry best practices to create sustainable competitive advantages and drive business growth. So, with this brief introduction of Mayank, it's a great pleasure inviting him for this session. Mr. Mayank, please, the session is yours.
Thanks a lot, Dr. Rajesh. Thank you, Nalinji, Dr. Nalin, to giving me this opportunity. So basically, I work for Telecom Industry, okay, and in the past 35 years, we have seen a lot of changes, in the telecom industry as well, and the way how we are working in the industry. So if we go back like to 20 or 30 years back, we can see like most of our things are manual, and a lot of things we are doing through file systems and all those things. But with the advent of computers and with the advent of softwares, so our way of working altogether have been changed. So I'm just giving a brief introduction, like what I'm going to cover in this complete session. Before coming to like what are the AI applications in telecom industry we are having currently, I want to go in detail like how this telecom industry overall evolved in the past 100 years, and from where we have started, and what are the key phases in which we have seen, like what are the major milestones we have achieved in the past 100 years in terms of telecommunications, and where we are standing today, and the massive change we have seen in the past 25 years, of course. And with this, I'll start my presentation. I'll turn off the camera just for the sake of bandwidth again. we are in a telecom industry, but still bandwidth is very important, right?
Agreed.
Yeah.
Okay. All right. Let me share my screen now, my presentation. All right. So for agenda, so we will talk about the telecom evolution, specifically on the GSM terms, because I work for a company which provides GSM services. So in the GSM is Global System for Mobile Communications. So we start our journey from 0G till currently we are at 5G, and research is going on for 6G. So we will cover like each of the GSM generation in detail. Then what was our traditional communication systems right from the beginning, like from the landlines, and how it have been converted into a data-driven network. So that we will cover. What are the key requirements for a voice communications, that we will cover in this session as well. Then how is our current telecom tower, and what are the major components of the telecom tower. So if we are having different cell sites, So in each cell site, what are the major components, how we are constructing a tower, how we are what kind of equipments we are installing in that, what are the functions of those equipments, and what is the process around all those things. This will give you a gist of what we do. And then we will cover when the process is covered, then we will cover like how we are implementing AI in that process now. So how we were working earlier and how we are working with the advent of artificial intelligence. Then after that, we will cover some more use cases which are still in progress, which have not been implemented yet, but uh, it's a next gen kind of use cases which we will discuss. Okay. Now coming to telecom evolution. So this whole global system for mobile communication, it started in you know uh, in the year mid 1940s basically. So there it was not at all mobile as well. It's a kind of a mixture of a wireline system and a wireless communication system. So and that time we have a very massive mobile communication devices. It also calls a car mobile basically. So if you want to have a mobile communication system, you have to set up that big equipment in a car, okay, or in a truck, and then that truck is mobile. And it also, like if we are talking about the 0G, then we need a manual operator, a switchboard operator. So we cannot call any particular number directly. So we have to connect wirelessly through a manual switchboard operator, and then he will connect us to the required destination. So it is not autonomous as well, and it is not wireless as well. So our connection will be established, the dialer connection will be established to a base station, and that base station, the guy on the base station will connect you through the wireline services, and that wireline services again will go to the destination, the person who's receiving the call. So that was 0G, and we have worked with this 0G technology till 1980s and till 1970s. So in 71, somehow we have removed this wireline services in between. Okay, now we can, our devices are more compact by 1971, and we are completely we have gone mobile. Though there were a lot of latency in the voice communication, as well as the voice quality is very poor as well, because there is no specific like 1 kb or 2 kb bandwidth is there for mobile communication, which is not apt for the whole human voice. So poor quality, latency, but the only advantage for 0G is that we were able to talk on a wireless medium. Okay, then in 1981 we have introduced a 1G system, which is again it's an analog system. We have not switched to digital yet. It's an analog system, and it is based on the FDMA standards, which is frequency division multiple access. And the communication channel in 1G is of 2 kbps. Please note these communication channels, like how we have involved in terms of bandwidth as well. So 2 kbps again, it's a very low bandwidth for human voice communication. Okay, and with this 2 kbps also, though it is wireless, there is a slight improvement in the voice quality, but still very poor in transmission, and call drops and all those kind of things are very frequent in this kind of technology. After this, till now, till 1G, it's all analog signals which have been transmitted from one place to another. With the introduction of 2G specifically in early 90s, okay, then we became digital. Okay, so this was the first digital communication which have been introduced in telecom industry, and we have used this actually is the first this basically use GSM as well as CDMA. You might have known, remember that there was a mobile phone which was launched by Reliance, Dhirubhai Ambani, pioneer of it is known as DAPO as well, that white color mobile. So that mobile communication was based on CDMA, okay, which is code division multiple access, and the rest of the mobile system used GSM technology, global system for mobile communication. So this is how, like in 90s, we have started using this 2G technology, and our main standards were GSM and CDMA for this. Now the speed for 2G is increased to 14 kbps. It ranges between 14 kbps to 64 kbps. 64 kbps is an extremely valuable terms in terms of voice communication. We'll go for this, but go in detail with this 64 kbps, like why it is important. But for now, please note that 64 kbps is the de facto bandwidth required for voice communication. In this in this 2G technology, okay, we have improved call quality. We have introduced a new feature in the communication system, which is called the text messaging as well. Okay, and by this time, the devices which were of a size of a car are now shrink to a mobile device, which we can which is affordable, and we can carry, a common man can also afford it and carry with them. Okay, and then another game changer is the 3G technology. So the third generation of mobile communication, so it gives us a lot of new features, a lot of value added services as well. First of all, high speed internet. This was the first uh, technology which have given us a broadband facility in mobile phones. Okay, and it also combined voice with data as well. So not only voice communication we are doing, we are also sharing the multimedia pictures, we are sharing videos, we are sharing SMS and MMS are also another part of 3G technology. So as of now, we got the gist of, okay, how we can share the data through mobile phones. Okay, but still it is not real time, right? So with the advent of 4G technologies, the bandwidth for 3G is from 2 Mbps to 10 Mbps. Okay, but uh, with the enhanced versions, of course. But still, live video streaming, gaming, and these kind of things are still, there is a huge latency in the 3G network. So to counter that, the next generation is the 4G, fourth generation of mobile communication, where we have services like voice over IP or voice over LTE. LTE is long-term evolution, which is an advanced version of 4G technology. It's kind of a mid of 4G and 5G, and these kind of services again change the communication system between industries. So you might have seen, like in mid 2010s, a lot of companies have started using VoIP phones, voice over IP phones, and these are the services which are wireline services as well. The last mile is a wireline service, the access layer, in the access layer, and the core is somewhat the transmission services or the IP based services. Okay, now we are into an era where we have introduced in 5G rollout. Okay, I was a part of a 5G rollout for a US based customer, and the infrastructure. Of course, we have to make a lot of changes in the infrastructure, but the major advantage of 5G rollout or 5G customers are not the retail customers. Basically, the major advantage do not goes to the retail customer, but to the enterprise customers. Okay, as of now, how this enterprise communication works is, like, suppose you have an office in Delhi and you have an office in Mumbai and you have an office in Chennai. So companies have lease lines. or virtual private networks. Okay, and in the core they have this fiber optic networks as well. But with the advent of 5G networks, our bandwidth capacity increased to around 6 GB. So with such a high bandwidth available, in the access, when I say access, it's a last mile connection. Okay, so the access of this bandwidth is easily available to the companies, and there are other lot of advantages of 5G as well. I said that it's not very, because all the services like VoIP, video streaming, gaming, medical emergencies, and all those things can be catered by 4G as well. First thing first, 5G have a very less latency rate. It's like 1 millisecond of latency. So 5G communication can be used in critical services like remote operations, like remote surgical operations, I'm saying, then self-driven cars. So in automobile industry as well, we can use this 5G technology for self-driven cars. We can use it in medical industry. We can use it in defense. So where a very precise decision needs to be taken in a real-time scenario. Okay, so now this 5G technology. So this is one story which is going on, right? And there are other parallel stories which are going on. So say, for example, I told you, like in the beginning of this, when we introduced 0G, 1G, 2G, our equipments were very large and cumbersome. Okay, now we have made a lot of progress in microprocessor industry as well. All our circuits are now, shrinked to a size of a button. So that helped in reducing the size of our mobile communication devices as well. So that is another story which is going on parallel, which is helping out our industry as well. Similarly, there is another channel of cloud computing and storage is going on, which will help us, or big data is going on, which will help us in uh, increasing the storage capacity or computing ability of devices. So all these parallel stories, and again, AI is also it's a latest technology which we have introduced in the corporates as well. So all these technologies are amalgamating to give a better products, right? And we are going in a futuristic next generation, so that all these technologies can combine and give us a very good products. So as you see, like I have explained, like the evolution of telecom, how it was in 1940s, and how it is currently we are in which state. The next stage is the 6G communication, and believe me, with the advent of 6G, all our devices will be interconnected. Our mobile phones will be connected to our helmet. We will be connected to our home systems. So everything is connected to everything with the help of IoT, and the 6G will be driving all these applications. You can see the number of subscribers also, how the number of subscribers have increased in the past 100 years. Earlier, like when we if we start with 1900s, so it was circuit switch network, circuit based switching, and only telecom lines, wireline services with manual operators. So those kind of services are there. Number of subscribers were very less. Even in 1920s or 30s, only universities and defense are using these kind of communication system. But you can see, like, the major change is when we have moved from circuit switching to packet switching. I'll explain this circuit switching and packet switching in the next slide. But this was the major game changer in telecom industry, when we switched from circuit based communication to a packet based communication. All right, any questions? All right, I'll move to the
Yeah.
next slide. Yep.
Yes.
Okay.
Yeah, I think no questions. You can move on.
Sure. Thanks, Dr. Rajesh. Okay, so I'm so sorry about a little formatting errors here. Somehow it got my font is changed. So anyway, moving on. So when we are talking about the traditional phone system, okay, or the circuit switching, so basically it is based on, it's a dedicated line which is created, a physical line or a virtual line which is created first for before any kind of communication, and then there is a communication phase, and after the communication phase the final is the tear down of that call. So you remember when we are having this telephone systems with us, like for example PSTN. Okay, so those kind of systems when we have, or ISDN network as well. So those kind of systems when we have, when we pick up the call, there is a signal to the telecom system that okay, now we have to reserve a line. Okay, this line is will be used for this call only, and it will not be shared to any other communication. Okay, when we dial a number, okay, it gives the destination address to the communication system, and there is a ring. So now the line is set up, now the circuit is set up, and then when the other person picks up the call, the communication phase, and when the conversation is over, then there is a call tear down. Okay, now earlier it was all manual. As I told you earlier as well, there was a manual switchboard operator who used to get all the calls to himself, and then he will connect you to the other party. So the major advantage for circuit switching is that there is a good quality in terms of latency, because a dedicated line have been given to the users. But as the number of users started increasing, it was very difficult to give a dedicated line to a particular user. Okay, and most of the time, between the gap of the speeches and all those things, so that line is getting wasted as well. Bandwidth is money. So since and this led to the invent of our modern communication system, which is called the packet switching. So in packet switching, it is more of a mail system kind of a system, where we are sending, where we are basically cutting down our data into small packets. And with each packet, we are putting a destination address. Okay, there is a header in which our source address will be there, like an envelope, right? So our source address will be there in that. Our destination address will be there in that. Inside that packet, what is the data? Okay, that payload, the data payload will be there, and then some error checking information will be there. Like for example, if you are sending a mail to from Delhi to Mumbai, you will put the Delhi address, you will put the Mumbai address, you will put a stamp, and you will put a letter. Okay, and then you will send it to one location to other location. It doesn't matter whether it goes via Hyderabad, whether it goes via Goa, whether it goes via Pune. So but it should reach the destination. So it is kind of a so all the packets which are created at the source, are going through different channels to a final destination, and it is using the best route possible, when it comes to getting to the final destination. Okay, where the traffic is low, where the speed will be high. So the issue with this particular packet switching, though it is very good in terms when the number of users increases, okay, and because we have a shared environment in packet switching, so it is very good. Like when we have like more number of users but moderate quantity. So when we have more number of users, at least everyone will get the service. There might be some latency, but like circuit switching, if the circuits are over, like the number of circuits which have been dedicated, if those are over, then there is no service after that. All lines in this routes are busy, right? But in packet switching, we don't have such kind of restriction. You will get everyone will get latency if the number of users are very high or the traffic is very high, but at least they will get the data in time. Okay, now this is for both voice and data communication. Okay, I have told you earlier, like 64 kbps is a dream number in de facto number in telecom system for voice communication. Why it is? Because earlier, if you remember, when we were using 2 kbps speed or 16 kbps speed for voice communication, okay, we can have some voice communication, but uh, the voice will be distorted. There will be call drops as well. Why it is so? Because our human voice ranges from 300 hertz to 4 kilohertz. Okay, and because of this 4 kilohertz range, so when we are digitizing any analog signal, right? Our voice is an analog signal, so and when we are digitizing it, and we have to regenerate it at the destination. So then we have to sample those that analog signal uh, with twice the maximum frequency. Basically, there is a theorem called Nyquist theorem, which says that if you want to regenerate a signal at the destination, then you have to sample that signal. You have to take the sample of that analog signal twice the frequency of that analog signal. So maximum frequency, twice the maximum frequency. So our maximum frequency here is 4 kilohertz, right? So we have to sample it 8,000 samples per second. So in a second, we have to take 8,000 values of that analog signal, so that that can be regenerated at the destination end. So for each then we have to, of course, we have to do a lot of other stuff as well. Once this is sampling is done, then we have to do a normalization of that sample. Then we have to do a quantization as well. Quantization is nothing but to store the value of that particular sample, we need 8 bits of bandwidth. Okay, now we have 8,000 samples, 8 bits per second. 8 bits we need for one sample. So total is 6,400 bits per second of speed we need to properly communicate that information, that sample information, to the destination, from source to the destination. So that's the reason I'm saying that 64 kbps is the ideal bandwidth, which is not doing any kind of compromise between the voice quality and the latency. So based on this 64 kbps only, our initial digital communication system, like piezochronous digital hierarchy or synchronous digital hierarchy, so those kind, or DWDM, so those kind of technologies are based on this 64 kbps voice channel. So this is called a T1 signal basically. So in this T1 signal, again, say for example, if I take an example of PDH or piezochronous digital hierarchy, so we have 32 such T1 channels, which creates one Ethernet signal, one E1 we call it, and we provide that E1 to a company, and that company can use 30 voice channels for them for communication. Okay, 31st and 32nd is for your signaling purposes and all, but they have 34 communication channels ready with them digitally. So on this 64 kbps, we have developed our communication system, voice communication system. So I think this gives like how we were working earlier, and with the communication system, with voice communication, how we are working now. Now coming to the GSM technology specifically. So in GSM, we have multiple cells basically. So one tower will cover an approximate area. Okay, depending on the number of users as well, what kind of load it can manage. So all those information we gather, and we start installing one tower. Okay, and each tower, when we are adding each tower, we have to integrate the new tower to the existing system as well. So when we are talking about GSM technology, then these are the cells which construct the entire network. Okay, now we are going to discuss like what are the major components of a tower. Okay, first of all, we have to build a tower structure. Normally it is a steel structure. There are different type of towers as well. Monopole are there, dipole are there, then complete mesh steel structure towers are there as well. So depending on the requirement of the users there, we have these towers installed, first of all. Then the major component is antennas. Then we have BTS, base transceiver station, which is nothing but the shelter there in which we have different equipments, different type of cards are there, different type of equipments are there. We have two units. One is the baseband unit and one is the remote radio unit, which is called RRU. Okay, so one is installed inside the shelter, and one is installed remotely near the antenna. So, and there are feeder cables which connects the antenna to the base transceiver station, in which we our baseband unit is installed. Okay. Then we have RF combiners and splitters as well. These RF combiners and splitters are very useful in terms of 4G and 5G technology, because it combines and it splits the frequencies, based on the number of users. Say, for example, in an antenna, suppose if an antenna is a 360-degree antenna, then in that antenna, there will be three sectors. So 120, 120, 120. So each sector will have their own frequencies, but we have to sometimes split those frequency, or we have to combine those two frequencies as well. So this RF combiners and RF splitters is doing that that kind of function, depending on the current load of that tower, where we require more frequency, where we require less frequency. So those kind of splitters we need in the tower installation as well. Now, when we are coming to the base transceiver station, we have radio equipments, we have power system, and we have cooling systems as well. So radio equipments, basically, I told you, as I told you, that remote radio unit or the baseband units. So these are the few components which we have in base transceiver station. And we have the power system for the whole equipment system there. And of course, we need an AC there, because of the very high heat these equipment generate. Okay, so these are the major components of a telecom tower. Now, I'm going to the process through which we build this tower system. There are a lot of things actually when we talk about a tower installation. There are multiple teams which are working independently, which are which have their own processes, and then we have to stitch all those processes to form to build a tower, first of all, to install the equipments in those towers, and finally to present that tower to the customers. Our customers are basically the ISPs, the internet service providers like ATAL or RGO or T-Mobile in North American market. So basically, we have to stitch all these individual processes so that we can install the tower as per the customer requirement. Okay, now before any such kind of construction of tower, or before any such kind of installation or integration of site, customer will give us some kind of checklist. Okay, my requirement is this. I need a tower built for these many users. I need a tower built with these specifications. These kind of labeling or cabling standards should be used. These are the equipments I want. Okay, and with all this kind of information, various teams are working in a different, and also the government norms as well. Okay, so while constructing before constructing the tower, or before starting any of the work, we have to do a site survey. Now, as I told in the beginning, earlier we used to do a lot of manual things. So when we are talking about the site survey, okay, the first process, okay, earlier our our engineers and our supervisors go to the site, okay, propose construction, and then they will check each and everything manually. Okay, and they will check, okay, whether the line of sight should be there. Okay, in case of a monopole tower, line of sight, because it's a point-to-point communication, so line of sight becomes very important. Okay, there should not be any kind of trees between the two antennas. There should not be, if there are trees, then we should have the permission to cut those trees as well. So I'm not going into controversies, but yes, for some of the cases, it becomes very important. If we want to install anything, then line of sight is extremely important. Okay, then whether there are any access issues to the site. Okay, are there any legal issues on site? So all these kind of things, we have to consider all the stakeholders. We have to see whether that place is apt for constructing a tower or not. Okay, with all these site survey details, we create a document, which is known as the fixed plan. Okay, once the planning is done, okay, how we are that all the necessary requirements to construct that particular tower is okay, then we go for, in parallel we are also working for the material management, whether the requirements from the customer side, all those equipments are available with us or not. We order because we create those equipments, we make those equipments in our factory, then we should have all those equipments available in our godown. And last mile logistic as well in parallel. So we have a team of project managers which who will take care of first of all the material, all the cards should be there, all the AC components or cooling systems and power systems and all those kind of equipment should be there at the dropout point near the site before any technicians start working there. So we have to make sure that all these you know um, uh, requirements are fulfilled before our field technician goes to the site, because these field technician, they are our suppliers basically. So when I say suppliers, so they are on contract who will go on site, and they only know like how to install a site. They will not be knowing anything about what customer have requested us, what is the requirement from the customer side and all. They just know like how to install the equipments. So we have to have a very strong communication with them, so that we fulfill the customer requirements as well. So once the site is installed, okay, once all the equipments are installed in the site as well, okay, now we have a solo site with us but with no life. Okay, then comes our commissioning team. So they will create a source code file which will this, as I told you, this network is kind of a mesh kind of network. Whenever there is a new tower introduced in the network, we have to configure that tower, and then we have to integrate that tower to the complete network. Okay, when we are configuring that tower, we have to give all the information, who is your neighboring cells. Okay, and in case if some traffic is there is a high load on this tower, then some traffic will be shifted to this tower. So those kind of configuration, those kind of parameters we have to provide in a source code file which is called the SCF file, and then we configure and commission that particular tower. Once we commission the tower, again, tower is live now. Okay, we can check, we can do a lot of UATs on that tower, whether that tower is catching the signals or not, or the communication between the tower and the user is okay or not. But again, this tower is not integrated with the system. Now before integration, we take some parameters value. Okay, what is the performance of the network? Okay, before this integration, we take those values, we capture those values, then we integrate the site. And post integration, again we check those parameters, so that there is no variation between the previous performance and the current performance. In case if there are any kind of variations, then again we deintegrate the site, we correct the parameters or the issues with the isolated site, and then we again integrate it. So this way, now our site is integrated with the network. Now the most important thing comes up. Okay, our site is ready, it is integrated with the network, everything is good, right? Now the most important thing is money, right? So until and unless customer accept our site and customer confirms that all the parameters which I have given you to build, on those checklists, have you built the site on those checkpoints or not? Build the site on those checklists or not? So to confirm that, we have to provide the complete information of that particular site with proofs to the customer. This is called a handover package or a site closeout package. Okay, so we capture each and every detail. What was the initial plan? What was the requirement from the customer? What was the standards which we need to use for that particular, and these standards or these checklists, it changes with the customer. I have one customer in North America who have different standards. I have one customer in Australia who have different standards. So based on their standards, we have to create our process of creating a handover package, and then we have to provide that complete handover package with all the photos, all the artifacts to the customer. And if customer rejects the package, that means he's rejecting the site. That means we will not get the revenue, and that becomes a non-FTR for us, non-first time right for us. Okay, so basically our team in this whole process see the acceptance by customer. Okay, now we are going to go in detail in acceptance by customer, and then we will discuss like how we are using now AI to do this acceptance for us. Okay, this is a process flow of our how we are working in acceptance. Now, when we are talking about site acceptance, we will get a site schedule. Like today, these are the field technician who are going on site, and that kind of schedule we will get. Okay, then we'll have a meeting with all the stakeholders. We'll have a meeting with the supplier. Okay, what are you going to do today on site? Okay, and based on their scope, we will enable our validation tool. It's a tool basically where they can upload the artifacts, upload the photos, of the scope which they are doing based on the customer checklist. Say for example, customer having 5 checklist for external photos. External photos means antenna photos, or a cabin photo, or the surrounding photos. So we will have some checklist for those. So our technician on field will give us photographs digitally. Earlier, as I told you, we used to have a manual photos, a physical photo of the site, and we have to create a file, and then we have to send it to the customer. And then after 2 months or 3 months, they will review the file, or they visit the site, and then they will finally approve or reject it. So the delay in this system, it was very high. So then we made it digital. Okay, now we are getting digital photos. We are creating a handover package. In case if we feel that something is not right as per the customer guidelines or as per the customer requirement or their checklist, then we go back to the supplier. So I'll just go like one by one here to the flow. So once we get the schedule, we have a discussion with the suppliers, and we get the supplier details so that we can enable the validation tool for them. A minute, let me see if I can use a pointer. Okay, now once the field technician visit the site, he will start uploading the photos and documents in the tool. Okay, our reviewer here in India. Now this field technician can be anywhere. It can be in US, it can be in Spain, it can be in Europe. So once this validation tool is, we have the access of this validation tool. Against the checklist, we will validate the photo, whether this photo is correct or not. Okay, digitally, and then once if we see like if something is wrong with the photo, we will send it back to the field technician, and if it is okay, we approve it. And then once we have all the approved artifacts with us, all the checklists are completed, then we create a handover package and submit to the customer. Okay, in case customer rejects the inputs provided, then they will come to us, and we will again give it back to our supplier to correct it. But it will be a non-FTR site for us. Okay, what are the key issues we were facing in this? Of course, first is the human errors. So when we are talking about human errors, suppliers give us blurred photos, suppliers give us wrong photos, suppliers upload some other sites photos to us as well, just to get it approved. Okay, so we have to be very vigilant, and we have to be very focused while reviewing the photos. And of course, there are some areas when we can get human errors as well. Okay, even we approve a photo which should not have been approved. Second thing is high turnaround time. So for each photo, it takes around 3 to 5 minutes of time to review, because we have to check every detail, whether that photo is okay to go to the customer or not. If something is wrong, we have to write the comments specifically stating what is wrong with this photo, based on which standard I am rejecting the photo, so that our supplier can understand, okay, what he needs to do. Even after that, putting all the comments as well, supplier will again call us and ask us, okay, what are the issues. Okay, that gives us the third pain points: communication delays between stakeholders, because we have to explain them, or explain all the stakeholders, in fact customer as well. Sometimes they reject us, reject our artifacts when they shouldn't have. So we have to have one discussion open with the supplier. We have to have a discussion open with our customer as well. So all these things were there. So we thought of a process. Okay, why not we implement a AI system, because we have a lot of approved and rejected photos with us, and through which we can very easily we can have one generative AI, and we can have that system trained to identify a good batch of photos and a bad batch of photos. So we have introduced in our system the AIML process in our system. So now if a field crew is going on site, he will request a pre-check in the AI system. The AI model is trained for each checklist. What are the good set of photos? What are the bad set of photos? For each checklist, initially we have trained for with 500 photos, good photos, and 500 bad photos. And then now, like, because suppliers keep on pushing photos in our system, now this database is around 1.5 lakhs photos. Okay, for each checkpoint. So when a supplier goes to a site, he will click the photos, he will upload the photo to a particular checkpoint. AI will take that checkpoint information, and AI will take that photo and gives it to the system to check whether this photo is from the good batch of photos or the bad batch of photos. Based on that decision, AI will approve or reject the photo. So now, before it comes to us, supplier knows that if it goes for a manual validation also, it will approve. Of course, the ones which AI rejects, then we have to pitch in, and we have to give the specific reason why this have been rejected by AI. Okay, when we started, our accuracy rate for AI was around 89%, but now with more and more photos training the machine behind it, so now we have an accuracy of around 98-99%. It varies on month basis. But yes, now our customer is also having that kind of confidence with us, that okay, if if AI is validating the photos, then also we will be having a high accuracy rate. So now this is one use case which we have for which we have implemented in our site acceptance process. Along with that, there are some other use cases as well. Some of them are already implemented. Some of them we are still working on. The other implementation which we are doing is predictive analysis through AI for site completion schedule. Now we have submitted like thousands of sites till now. Okay, for different customers. We know like how the geography is impacting the site schedule, how uh, the location is impacting the site schedule, what kind of things which can go wrong for any particular location, any particular time, or the information of the warehouse, like whether the material is there or not, whether the material is there in the dropout point or not. So all these things, all this information will give a prediction of when the site will be completed. And this gives the confidence to the customer as well. Okay, based on all these factors pitch in, I know like when my site is going to be completed. Okay, so this in fact reduced lot of the governance part with the supply with the suppliers as well as with the customer as well, because everyone knows, okay, if the orchestration is correct and our AI prediction is validating that orchestration, then our site will be handed over in 3 weeks of time. Okay, in case of any kind of delay, or in case of any kind of variation in that orchestration, again it will go as a learning to the AI. So AI engine is continuously learning, and we get a very good prediction of the site completion. This is something which have been implemented as well. Then I have already told you like how the AI system is working for validation. Now, we have a lab here, okay, and we have developed the concept of VR goggles through which we can do a quality check as well. So my reviewer here have that VR goggle with them, okay, and there is a drone with camera on site, and with the help of that drone we can click the photos from here itself. We don't need any field technician specifically going there on site to take photographs, and those kind of photographs which normally we reject because the photos are not correct. So we can click the photos from here in Chennai, click the photos of site in Australia with the help of drone and with the help of a normal camera. Okay, and that photos will go to our handover package which will be submitted to the customer. So this saves a lot of truck rolls as well. So actually for each truck roll, for each site visit, it takes around $2,000 there in Australia. Okay, if we can save one site visit, we are saving around $2,000. So this is the second example of quality check through AI which we are performing. The third is AI for performance and potential risks. Now, again, this is a AI driven, data driven AI. Okay, we have the information of which supplier, which crew member is doing what kind of error. Okay, and based on that, there is a predictive model which can predict, okay, if this supplier is going on site and this is the crew member who's working on the site, these are the specific things which he needs to take care. Based on his past experience, he have made these kind of errors. And before going to the site, supplier have that information. Okay, I'm going on site, these are the things which I need to take care. So potential risk of failure and potential hazards as well. So all those things can be avoided by giving prior information to the supplier that, okay, these are the things where you need to be very careful. As I told you that we are working in a global environment, right? So we are in Chennai. We are comfortable in English, but we have customers who are in Spain, who are in Portugal, where we have different languages. Okay, so we have made created one AI model. Okay, and that AI model basically use the neural networks for translation of language, a language translator basically. So that also we have created, and now it's under POC as of now, but somewhat maybe mid this year we will have it implemented in our global service delivery center. Okay, the last one is extremely important because it is related to the safety. So when a technician is going on site, so the technician is have to follow a lot of safety parameters as well: helmet, PPE kit, and safety nets and all those things. So we have developed a VR goggles, or it can be we can also run it through our mobile phones as well. So any kind of hazard on site, say for example, a net is broken. Okay, so it will give a red flash there that the net is broken. Okay, if you move that camera to a site and you see that a railing is broken, so or a parapet is broken, so it will give that red light there that these are the hazards on site, which or asset tub. Okay, so supplier will know that what are the hazardous things on site, and it will give a very good perspective to the supplier that what need to be corrected on site. So these are some use cases which we are planning in our processes now. So that's it from my side. Any kind of questions, then I'm happy to answer.
I have a general question, Mayank.
Yeah.
Yeah, I mean, these days people are going crazy about AI and ML and want to implement it everywhere. So before AI, how was it done? The same case study. Is it really helpful to the company, or in this case, and how it is beneficial introducing this AI?
Yeah. So basically, I'll give you a perspective in terms of time saving. So as I told you, the photo validation part. Okay, we used to take around 5 minutes, 6 minutes of time to review a single photo. Okay, now this is automatically being done. And we just have to spend around 30 seconds of time just to ensure whether what AI have rejected. So to put the comments to explain our supplier. So that's a saving of around 4.5 minutes. And with that, there is a lot of productivity gain as well. So definitely, implementation of AI, ultimately, it's productivity improvement. So once the productivity, productivity is money, right? So definitely all these kind of digitization, all these kind of innovations, not only it will help in improving the quality of our sites as well, but also the productivity gain as well.
Okay. So this software is developed by Nokia for other customers.
Sorry? No,
This,
this is just for our own processes only.
okay.
Because this AI is also embedded in our validation tool. So this is something which we have done in-house, and we are using it internally.
Okay. So that's all from my side. Participants, if you have any questions, please, you can unmute yourself or you can type in the chat. You can ask directly to the speaker.
Nice.
I hope I have given a little insight on what we are doing, and when we hear the company name, right? So first thing comes, okay, this is a company who make mobile phones,
Yeah.
right? But that is not the case now, and we are going in different sectors now as well, in medical communication and in defense communications as well. So and this was the pivot which was done after this Microsoft failure, right? So with Nokia. So then
Android failure, Microsoft failure. Okay, sorry. Yeah.
we were the Windows phone, right?
Yeah, correct, correct.
So
I
we
think
have not
Nokia was the one
adopted.
which rejected the Android software, right? Initially.
Yeah. Initially,
Yeah.
actually, we didn't go for Android.
Yes.
When Apple launched iOS, everyone was adapting Android, but we were the ones who adopted. We tried Windows Phone,
Windows.
so which
Right.
was not a good move.
Yeah, of
So
course.
so we have pivoted from that, and more or less we are more into telecom equipments. We are the pioneers of this GSM technologies as well.
That's great.
Good.
Nalin sir, anything from you?
Yeah. No. We used to discuss, so I don't want. Yeah, we discuss a lot actually, so that's why I say I'm not opening my mouth here. And I'm expecting some participants to ask some questions because we have many of them communication and electronics engineers there. So I was hoping some participants will ask some questions. But to summarize, Mayank, you have provided a nice glimpse of the history of that evolution of the telecom industry, and then you have explained very well how what currently Nokia is doing, what is the current work methodology, and how AI has influenced or enhanced your working methodology kind of thing. So thanks, man. It was nice.
Yeah. Yeah. Thank you, Mayank,
Thank
for your
you.
time.
Uh, Rajesh, can you share the link for the feedback?
Yeah, I'll share.
So,
I'll share.
so Mayank, we'll collect the feedback and then I'll get back to you with the feedback once they provide it. Okay, I will circulate the feedback to you.
Sure.
Okay, so they will provide the feedback and you can use it for the use. And once again, thanks, man. Okay.
Mhm. Okay. Thanks a lot, Nalinji, and thanks a lot, Rajesh ji.
Okay.
Thank you, sir. Have a good
Thank
day.
you.
You have a good night. Good night, man.
Good night.